Imagine gazing up at the night sky and realizing that everything above you and everything beneath your feet are deeply connected. Earth and space are not separate stories. They are one continuous narrative, written in starlight and etched into mountains, oceans, and time itself. Tonight, we will drift through that gentle overlap, where astronomy and geography embrace. Welcome to this calm journey. 30 Space and Earth Overlap Facts, where geography meets astronomy. Over the next 2.5 hours, we will glide through the mysteries of time zones, the dance of the seasons, the shadow play of eclipses, and the elegant paths of orbits that govern our days and nights. Each fact will feel like a stepping stone across a cosmic river, carrying you deeper into both knowledge and rest. Before we begin, I invite you to take part in this global conversation. If you enjoy this tranquil exploration, please like and subscribe, only if it brings you peace. And in the comments, let us know your country, your city, and the time of night or day when you are listening. Together, we create not just a community, but a quiet constellation of viewers across the world. And so, let us begin. Fact number 1. The reason Earth has different time zones is its steady rotation on its axis. Because the planet spins once every 24 hours, sunlight gradually sweeps across the globe. To account for this, the world has been divided into 24 time zones, each representing roughly 15 degrees of longitude. Geography and astronomy merge here, giving shape to the rhythm of human life. Fact number 2. Seasons are not caused by how close Earth is to the Sun, but by the tilt of Earth's axis at about 23.5 degrees. This tilt means that different parts of the planet receive varying amounts of sunlight throughout the year, leading to warm summers, cold winters, and transitions in between. It is a perfect example of how our planet's geometry and cosmic motion intertwine. Fact number 3. The equator, an invisible line circling Earth's middle, is not just a geographical marker. It is also an astronomical line. Regions along the equator experience nearly equal lengths of day and night all year round, while places farther north or south swing between long summer days and long winter nights. Fact number 4. Solstices mark the extremes of sunlight. The summer solstice brings the longest day of the year, while the winter solstice brings the shortest. These moments are celebrated in countless cultures as astronomical turning points and geographical festivals of light and shadow. Fact number 5. Eclipses occur because of precise alignments in space. A solar eclipse happens when the moon passes between Earth and the Sun, casting a shadow on our planet. A lunar eclipse happens when Earth itself blocks sunlight from reaching the moon. What feels like a celestial event is also geography in motion. Shadows falling on landscapes, skies darkening over oceans, entire regions pausing in awe. Fact number 6. Latitude and longitude, the grid that maps Earth, are deeply tied to astronomy. Latitude was first measured by observing the angle of the sun or stars above the horizon, while longitude was solved centuries later with precise timekeeping. The shape of our maps is, quite literally, written in the stars. Fact number 7. Midnight and midday are not just times on a clock. They are moments defined by astronomy. Midday is when the sun is highest in the sky for a location, while midnight is when the sun is furthest below the horizon. In this way, every hour we live is rooted in celestial mechanics. Fact number 8. The Tropic of Cancer and Tropic of Capricorn are not arbitrary lines. They are the farthest points north and south where the sun can be directly overhead at noon, marking the limits of the tropical zone. These lines are drawn not by human decision, but by the tilt of Earth in space. Fact number 9. The Arctic and Antarctic circles are the edges of another phenomenon. Within these polar regions, there are days when the sun never rises, and others when it never sets. Geography defines the locations, but astronomy defines the experience. Fact number 10. Even the calendar we follow is an overlap of Earth and space. A year is the time Earth takes to orbit the sun, about 365.24 days. The leap year adjustment every 4 years exists because we cannot ignore those extra fractions of a day. Our measurement of time is stitched together by the cycles of the heavens. Let these opening facts settle gently, like the first stars appearing at twilight. They remind us that our sense of place on Earth is inseparable from our place in the cosmos. With every hour, every season, and every eclipse. As we drift deeper into this journey, let us pause on something so ordinary we rarely notice it. Yet, so extraordinary, it shapes everything we know. The rotation and orbit of our planet. These simple, steady motions weave together geography and astronomy, creating the flow of time itself. Fact number 11. Earth's rotation on its axis is what gives us day and night. One full spin takes about 24 hours, but in reality, it is slightly less than that, about 23 hours, 56 minutes, and 4 seconds. Astronomers call this a sidereal day, measured against distant stars rather than the sun. Our clocks stretch this motion into a neat 24-hour system so that human life flows smoothly, even if nature ticks a little differently. Fact number 12. The orbit of Earth around the sun defines the length of our year. It takes approximately 365 days for our planet to complete this journey. But because of the extra 0.24 days, we add a leap day every 4 years. Without it, the seasons would slowly drift, and centuries from now, summer would arrive in winter's place. Geography's cycles of harvest, travel, and culture depend entirely on this astronomical precision. Fact number 13. Time zones are carved from Earth's rotation. Each zone spans about 15 degrees of longitude because the planet rotates that distance in 1 hour. Yet, human borders rarely follow straight lines. Political choices often bend these zones to fit countries, economies, and cultures, reminding us that human geography always dances with cosmic rhythm. Fact number 14. At the North and South Poles, time itself feels different. Because all lines of longitude converge, every time zone technically meets there. A researcher in Antarctica could set their watch to any zone in the world. A strange reminder that time is both a human agreement and an astronomical fact. Fact number 15. The moon plays a subtle role in how we measure time. Ancient calendars often used lunar cycles, marking months by the waxing and waning of the moon. Even the word month has its roots in moon. today. Our calendar leans solar, but echoes of the lunar rhythm remain in cultural festivals across the globe. Fact number 16. Earth's rotation is not perfectly constant. It slows ever so slightly over time, largely due to the gravitational pull of the moon, creating tidal friction. Scientists estimate that millions of years ago, Earth's day lasted only about 22 hours. Millions of years from now, it may last 25. The geography of our days is written in celestial gravity. Fact number 17. Coordinated Universal Time, or UTC, is the modern heartbeat of global timekeeping. It is measured using atomic clocks, so precise they lose less than a second over millions of years. Yet even these are occasionally adjusted with leap seconds to keep pace with Earth's natural rotation. Here, astronomy dictates the rules, but human technology enforces the rhythm. Fact number 18. The international dateline is another overlap of geography and space. Located mostly along the 180-degree line of longitude in the Pacific Ocean, it marks the place where one calendar day ends and another begins. Crossing it eastward, you step back in time. Westward, you leap forward. It is a line drawn by humans, but demanded by Earth's rotation. Fact number 19. Seasons are not just patterns of weather. They are rhythms of sunlight. When the northern hemisphere tilts toward the sun, days grow longer and warmer, marking summer. At the same moment, the southern hemisphere tilts away, experiencing winter. Geography determines where we stand, but astronomy determines what season greets us. Fact number 20. Equinoxes are Earth's balancing acts, twice a year, around March and September. The sun shines directly over the equator, giving nearly equal day and night across the globe. In these rare moments, geography feels united under a single astronomical truth, a planet poised in perfect balance between light and shadow. As this section closes, think of time not as numbers on a clock, but as the gentle turning of Earth beneath the sky. Every tick of a second, every calendar date, every shift in season, all emerge from this graceful ballet of rotation and orbit. We live inside a rhythm so vast that it hums softly beneath everything we do, grounding us to Earth while reminding us of the heavens. As we drift further into this journey, let us explore the beautiful dance of light and shadow across Earth. It is in the interplay of illumination and darkness that geography and astronomy most visibly overlap. Our world is painted daily by the sun and the moon, with shadows stretching across continents and beams of light marking our passage through time. Fact number 21. The line that separates day from night on Earth is called the terminator. At any moment, half the world is bathed in sunlight, while the other half rests in darkness. This dividing line is not sharp, but softly curved, shifting as Earth rotates. The terminator is geography painted directly by the geometry of space. Fact number 22. Twilight is not a single phenomenon, but three distinct phases. Civil twilight is when the sun is just below the horizon. Nautical twilight is when it sinks deeper, but stars become visible for navigation. And astronomical twilight marks the last faint trace of sunlight. These definitions reveal how ancient explorers combined astronomy with geography to chart the seas and skies. Fact number 23. At the equator, sunrise and sunset are rapid, because the sun's path is steep relative to the horizon. Day shifts to night in just minutes, but near the poles, the sun lingers low, making dawns and dusks stretch for hours. Geography sculpts how we experience light, even when astronomy governs the motion. Fact number 24. The polar day and polar night are among the most extreme examples of Earth-space overlap. Within the Arctic and Antarctic circles, there are seasons where the sun never dips below the horizon, and others where it never rises. For months at a time, life is shaped by either unbroken daylight or unending darkness. Fact number 25. Shadows are not the same everywhere on Earth. Near the equator, they can shrink almost to nothing at noon, especially on equinox days when the sun stands directly overhead. At higher latitudes, shadows stretch long, even at midday. Our sense of space is shaped not just by geography, but by the angle of sunlight. Fact number 26. Solar noon is a fascinating marker. It is the exact moment the sun reaches its highest point in the sky for a given location. It rarely occurs at 12 o'clock p.m. on the clock because time zones stretch and shift to fit human needs. Solar noon reveals the quiet difference between astronomical time and human time. Fact number 27. The phenomenon of the midnight sun is a natural wonder of the polar regions. In summer, the sun circles the sky without setting, glowing gold and orange at strange hours. This constant light transforms landscapes, ecology, and human rhythms, reminding us how geography bends under astronomical extremes. Fact number 28. Conversely, the polar night is equally dramatic. For weeks or months, the sun never rises. Yet the darkness is not complete. The moon, stars, and auroras take their turn illuminating the land. Life in these regions adapts to cycles that are written in space but lived on Earth. Fact number 29. The angle of light has shaped human architecture and culture. Ancient civilizations oriented temples, pyramids, and monuments to align with solstices, equinoxes, or cardinal directions. Geography gave them a location, but astronomy gave them meaning. The overlap was both practical and spiritual. Fact number 30. Lunar eclipses are an especially poetic expression of Earth's shadow. When our planet passes directly between the sun and moon, Earth's shadow falls across the lunar surface, turning it deep red in what is often called a blood moon. Here we see geography, the size of our planet projected into the night sky. Fact number 31. Even the glow of moonlight is borrowed sunlight. The moon reflects the sun's rays onto Earth, and its phases are simply the changing geometry of this reflection. Geography gives us the landscapes where moonlight falls, but astronomy determines how brightly those nights are lit. Fact number 32. Earth's atmosphere bends and scatters sunlight, coloring our skies. At sunrise and sunset, the light travels through more air, scattering short blue wavelengths and leaving behind warm reds and oranges. Geography determines where we stand, but the spectacle is pure astronomy filtered through air. As this section closes, imagine standing quietly at dusk, watching the horizon glow. The colors, the shadows, the length of twilight. All are born from the gentle embrace of earth and space. Light and shadow are not opposites, but partners, and together they shape the way we live, dream, and measure time. Now, let us lean into one of the most graceful overlaps between geography and astronomy: the seasons. The gentle tilt of Earth's axis, just 23.5 degrees, creates a cycle that influences agriculture, culture, and even the rhythms of human happiness. Without this tilt, the world would be unimaginably different. Fact number 33. Earth's tilt, not its distance from the sun, is the reason for the seasons. Many assume summer happens when Earth is closest to the sun, but in truth, the opposite is often the case. Earth is actually nearest to the sun in January. It is the tilt that directs sunlight more directly onto certain latitudes, warming one hemisphere while cooling the other. Fact number 34. The northern and southern hemispheres experience opposite seasons. When summer unfolds in Europe, Africa, north of the equator, and North America, winter cloaks Argentina, South Africa, and Australia. This mirror-image effect shows how geography is paired with astronomy in shaping our climates. Fact number 35. Equinoxes, which occur in March and September, are moments of perfect balance. On these days, nearly every location on Earth experiences about 12 hours of daylight and 12 hours of night. Ancient civilizations tracked equinoxes to mark planting seasons and ritual festivals. They saw these moments not just as astronomical, but as deeply spiritual. Fact number 36. Solstices in June and December are the turning points of the sun's apparent journey. The summer solstice is the longest day, when the sun stands still at its northernmost point before retreating. The winter solstice is the shortest, when darkness reigns, but light begins to return. These events are celebrated from Stonehenge in England to the temples of Peru. Fact number 37. Without Earth's tilt, there would be no seasons at all. Every day would have equal length everywhere, and climates would be locked in place. The equator would forever burn, and the poles would remain eternally frozen. The tilt is a small angle, but its influence shapes human civilization. Fact number 38. Monsoons, which feed billions of people across South Asia, are tied to the seasonal shifts in Earth's solar heating. As the land warms faster than the ocean, winds reverse direction, pulling moisture-laden air inland. This interplay between astronomy and geography sustains entire economies and cultures. Fact number 39. Seasonal variations also shape ecosystems. In temperate regions, trees shed their leaves in autumn, conserving energy for winter. In spring, they burst forth again, synchronizing with the return of longer daylight. Fact number 40. Some cultures developed calendars entirely based on the seasons. The ancient Egyptians, for example, aligned their calendar with the annual flooding of the Nile, which coincided with the heliacal rising of Sirius, a bright star. Geography and astronomy were bound together in both survival and celebration. Fact number 41. The midnight sun, experienced in Arctic and Antarctic regions during summer, is another extreme product of Earth's tilt. Here, the sun circles the horizon endlessly, never dipping low enough to set. The geography of high latitudes reveals the astronomy of axial tilt in its purest form. Fact number 42. Seasonal affective disorder, or SAD, is a modern reminder of how deeply human beings are tied to the sun's rhythms. In regions with long, dark winters, many people experience mood changes linked to reduced sunlight. Even our minds and emotions reflect the overlap of geography and space. Fact number 43. Harvest festivals around the world are echoes of astronomy written into culture. Whether it is Thanksgiving in North America, the Mid-Autumn Festival in East Asia, or Pongal in South India, celebrations of abundance are tied to seasonal cycles determined by Earth's tilt. Fact number 44. Even modern travel is shaped by the seasons. Tourism industries thrive during summer and winter peaks, depending on whether travelers seek warm beaches or snowy slopes. The global economy flows in rhythm with the axial dance of our planet. As this section closes, imagine Earth spinning gently on its tilted axis, orbiting the sun like a dancer leaning into the music. That small tilt, so modest on paper, is what gives us long summer days, crisp autumn evenings, and the rebirth of spring. Geography and astronomy are partners in creating the pulse of life. As we continue this calm journey, let us explore a system that touches all of us every single day: time zones. At first glance, they seem like lines drawn on a map. Yet beneath those lines lies the motion of Earth through space, its steady spin giving rhythm to human life. Time zones are the marriage of astronomy's precision and geography's practicality. Fact number 45. Earth spins at about 1,670 kilometers per hour at the equator. To keep pace with this rotation, the world is divided into 24 standard time zones, each covering about 15 degrees of longitude. This allows the sun to be roughly overhead at noon, wherever you are. Fact number 46. The prime meridian, running through Greenwich, England, is the starting point for measuring time zones. Known as Greenwich Mean Time, or GMT. It was established in the 19th century when global navigation and trade demanded a universal standard. Geography gave the line, but astronomy gave the logic. Fact number 47. Not all time zones follow the perfect 15-degree spacing. Countries often shift their official times for political, economic, or cultural reasons. India, for example, spans more than 2,900 kilometers east to west, but follows a single national time, Indian Standard Time, or GMT plus 530. This shows how astronomy's neat divisions bend under geography's. Fact number 48. China, though nearly as wide as the continental United States, officially follows just one time zone, Beijing time. This means that in Western China, the sun can rise as late as 10 a.m. in winter. Here, human decision overrides celestial rhythm, creating unique daily patterns. Fact number 49. The international dateline, mostly aligned with the 180th meridian in the Pacific Ocean, marks where the calendar shifts. Crossing it from east to west adds a day, while crossing from west to east subtracts one. It is a line born from Earth's rotation, but drawn with compromises to avoid splitting nations and islands. Fact number 50. Some regions use half-hour or even quarter-hour offsets, showing just how flexible human time can be. Nepal, for instance, is set at GMT 5:45, a precise choice reflecting both cultural identity and practical positioning. Geography and culture meet astronomy in subtle ways. Fact number 51. Daylight saving time is another example of humans adjusting astronomical time to their needs. By shifting the clock forward in summer, countries aim to maximize daylight for work and leisure. The practice may be controversial, but it shows how societies bend to the sun's seasonal rhythm. Fact number 52. At the poles, time zones lose their meaning. In Antarctica, researchers often follow the time zone of their home country or supply base, since the sun may not rise or set for months. This strange reality reveals that time zones are not natural but agreed-upon systems layered over astronomical motion. Fact number 53. Global business, tourism, and technology all depend on this web of timekeeping. From airline schedules to stock markets, from live broadcasts to international calls, the flow of modern life is possible only because time zones link geography with space. Fact number 54. Coordinated Universal Time, or UTC, now serves as the world's timekeeping backbone. Measured by atomic clocks, it keeps extraordinary precision, yet still adjusts occasionally with leap seconds to align with Earth's slowing rotation. Even the finest technology must respect astronomy's pull. Fact number 55. Travelers who cross time zones experience jet lag, a disruption of the body's circadian rhythm. Our internal clocks are wired to follow the cycle of sunlight. So rapid shifts in geography force the body to realign with astronomy. It is a reminder that no matter how advanced our technology, we remain creatures of earth and sky. Fact number 56. In some parts of the world, time zones have been adjusted to strengthen tourism. Spain, for example, follows Central European time, even though its longitude would naturally place it in the same zone as the UK. This allows for later sunsets, drawing visitors to evening strolls, cafes, and beaches. As this section closes, picture Earth slowly spinning beneath the sun, each line of longitude passing into light and then into darkness. Time zones are our attempt to capture this flow, to synchronize billions of lives across continents. It is a map where astronomy sets the rhythm and geography writes the details, keeping us all bound to the same cosmic clock. Now, let us drift into one of the most beautiful intersections of space and geography: the changing of the seasons. For much of human history, the passage of time was measured not by clocks, but by the cycle of growth, harvest, and rest. This eternal rhythm is not caused by Earth's distance from the sun, as many once believed, but by a quiet, graceful tilt. Fact number 57. Earth's axis is tilted at about 23.5 degrees relative to its orbital plane around the sun. This tilt is the reason why seasons exist. Without it, every place on Earth would experience nearly the same climate year-round, a world without spring or autumn. Fact number 58. During the Northern Hemisphere's summer, Earth is actually farther from the sun than during winter. The warmth of summer comes not from distance, but from the angle of sunlight and the longer days caused by the tilt. Geography absorbs and reflects these solar gifts differently in deserts, forests, and oceans. Fact number 59. The solstices mark the turning points of this cycle. On June 21st or 22nd, the northern hemisphere tilts most directly toward the sun, creating the longest day of the year. On December 21st or 22nd, it tilts away, giving the shortest day. Cultures across time built monuments, festivals, and calendars around these celestial moments. Fact number 60. The equinoxes, occurring around March 20th and September 22nd, are moments of balance. On these days, day and night are nearly equal across the planet. Ancient civilizations often saw them as symbols of harmony between light and dark, sky and earth. Fact number 61. The tropics of Cancer and Capricorn mark the latitudes where the sun can stand directly overhead at noon, something impossible elsewhere. Between these lines, the sun's high arc makes tropical climates lush and warm. Beyond them, the sun always stays at a slant, shaping temperate and polar regions. Fact number 62. In polar regions, the tilt creates the midnight sun and polar night. For months at a time, the sun never sets or never rises, turning geography into a stage for extremes. In Svalbard, Norway, the midnight sun lasts from late April to late August, while the long winter dark brings both challenge and wonder. Fact number 63. The seasons are not identical across Earth. In the southern hemisphere, the cycle runs opposite to the northern. While people in Europe celebrate summer in June, those in Australia are stepping into winter. Geography flips the script, though the astronomical tilt is the same. Fact number 64. Seasonal shifts influence not only weather but also the global economy. Agriculture depends on the timing of rains and warmth. Tourism thrives on seasonal attractions, from alpine skiing to Mediterranean summers. The cycle of seasons shapes when and where travelers seek luxury, leisure, and adventure. Fact number 65. The monsoon, vital to much of Asia, is a product of seasonal shifts. As land heats and cools faster than oceans, winds reverse their direction with the changing seasons, bringing rains that sustain millions. Here, astronomy's tilt sets off vast patterns of human geography and survival. Many species migrate, breed, or hibernate according to seasonal light, not just temperature. Birds crossing continents, bears resting through winter, and plants blooming in spring all are linked to Earth's tilted dance around the sun. Fact number 67. The tilt itself is not fixed. Over tens of thousands of years, it wobbles slightly, a phenomenon known as axial precession. This slow drift subtly changes the timing of seasons and has influenced ice ages and climate shifts across Earth's history. Fact number 68. Human culture reflects the seasons in countless ways: holidays tied to harvests, art inspired by autumn leaves, and rituals marking the rebirth of spring. Geography gives local flavors to these traditions, but astronomy sets the shared rhythm felt across civilizations. Fact number 69. Some equatorial regions experience little variation between seasons. Instead of 4 distinct cycles, they may have only wet and dry periods, shaped by the movement of the intertropical convergence zone, a belt of shifting rainfall driven by the sun's path. Fact number 70. In modern life, technology allows us to soften the extremes of seasons. Heating, cooling, and artificial lighting make winters less harsh and summers more bearable. Yet, even with all our advances, the tilt of Earth's axis still dictates how crops grow, how oceans circulate, and how light falls on our world. As we close this part, imagine Earth slowly orbiting the Sun, always leaning at its steady angle. The seasons are not random. They are a cosmic ballet, a choreography written by the tilt of a planet. From snowy peaks to sunlit vineyards, from bustling ski resorts to summer beaches, the rhythm of the seasons continues to shape human experience in ways both practical and poetic. Now, let us step into one of the most mysterious and awe-inspiring overlaps of astronomy and geography: the eclipse. Few events capture human imagination as deeply as the sudden darkening of the sky, or the brief glow of a blood-red moon. Eclipses remind us that Earth, Sun, and Moon are locked in a cosmic dance, and that our geography decides how we witness it. Fact number 71. A solar eclipse occurs when the moon passes directly between Earth and the Sun, casting its shadow upon Earth's surface. Because the moon is about 400 times smaller than the Sun, but also about 400 times closer to Earth, it appears almost the same size in our sky. This coincidence allows for the perfect alignment of total solar eclipses. Fact number 72. Not everyone sees an eclipse the same way. Geography dictates whether you experience total darkness, a partial shadow, or nothing at all. The path of totality, narrow strip across Earth's surface, determines where the eclipse is most dramatic. Those just outside the path see only a partial cover, while most of the planet continues in normal daylight. Fact number 73. During a total solar eclipse, day can briefly turn into night. Stars may appear. Animals behave as if evening has fallen, and the temperature can drop noticeably. For ancient peoples, this sudden shift was terrifying and often explained through myths of dragons devouring the sun. Fact number 74. A lunar eclipse occurs when Earth casts its shadow on the moon. Unlike solar eclipses, lunar eclipses can be seen from anywhere on Earth's night side. During this event, the moon often takes on a reddish hue, caused by sunlight refracting through Earth's atmosphere, a phenomenon sometimes called the blood moon. Fact number 75. Geography shapes how often you might witness an eclipse. Total solar eclipses are rare for any one location because the path of totality is so narrow. Some regions may not see one for hundreds of years, while others lie along repeat paths. Fact number 76. On average, Earth experiences about 2 to 5 solar eclipses and 2 to 3 lunar eclipses per year. Yet, not all are visible everywhere. This means that while eclipses are regular on a planetary scale, they remain special, almost magical, for individuals who experience them. Fact number 77. Ancient civilizations used eclipses as both omens and tools. Babylonian astronomers, for example, could predict eclipses with surprising accuracy, linking them to cycles of celestial motion. Mayan and Chinese cultures also recorded them carefully, weaving astronomy into their calendars and myths. Fact number 78. Today, Eclipses inspire global travel and tourism. People known as eclipse chasers journey to remote corners of the world to stand briefly in the path of totality. Tourism industries in these locations often see dramatic boosts during eclipse events, blending astronomy with economy and geography. Fact number 79. An annular eclipse occurs when the moon is slightly farther from Earth in its orbit. In this case, it appears too small to fully cover the sun, leaving a glowing ring of fire in the sky. The spectacle is less dramatic than total darkness, but equally captivating. Fact number 80. The longest possible total solar eclipse lasts about 7.5 minutes. This is rare, as most are much shorter. The briefness of the event adds to its mystery, as if the heavens allow only a fleeting glimpse of their secrets. Fact number 81. Geography influences not just who sees an eclipse, but how it is studied. For example, early discoveries about the sun's corona, the outer atmosphere visible only during totality, were possible because expeditions traveled across continents to capture the event. Fact number 82. Eclipses connect to both time and seasons. They can only occur during new or full moons, and only when the sun, Earth, and moon align with the orbital plane known as the ecliptic. These alignments are rare, and when they happen, geography decides which part of Earth is lucky enough to watch. Fact number 83. Eclipses also inspire cultural creativity. In literature, they often symbolize turning points, mysteries, or moments of revelation. In some cultures, they were seen as omens of great change, whether for kings, wars, or harvests. Fact number 84. Technology has transformed how we experience eclipses. Live broadcasts, high-resolution telescopes, and photography allow millions to watch, even if they are far from the path. Yet nothing matches the direct, silent awe of standing in a shadow cast by the moon itself. As this part draws to a close, imagine standing in a field or on a mountain, watching the sun slowly dim, the sky turn twilight, and the stars peek out at midday. Eclipses are the most dramatic reminders that Earth is not isolated, is part of a greater system, one where geography determines not only where we live, but how we witness the universe. As we drift further into this calming journey, let us turn our attention to Earth's orbit around the sun. This motion is the heartbeat of our planet's time, shaping the length of our years, the pattern of our seasons, and even the rhythms of human culture. While we often imagine Earth's path as a perfect circle, in reality it is a delicate ellipse, one that gently influences life across the globe. Fact number 85. Earth takes about 365.25 days to complete one orbit around the sun. That extra quarter of a day accumulates, which is why we add a leap day every 4 years to keep calendars aligned with celestial motion. Without this correction, our seasonal dates would drift slowly away from their natural markers. Fact number 86. Earth's orbit is not a perfect circle, but an ellipse. This means the distance between Earth and the Sun varies over the course of a year. At its closest, known as perihelion, Earth is about 147 million kilometers from the Sun. At its farthest, aphelion, It stretches to about 152 million kilometers. The difference subtly affects how much solar energy Earth receives. Fact number 87. Interestingly, perihelion occurs in early January during Northern Hemisphere winter. This shows once again that seasons are driven not by distance, but by the tilt of Earth's axis. Geography and astronomy weave together to create this balance, preventing either hemisphere from permanent extremes. Fact number 88. Earth's orbital speed is not constant. According to Kepler's laws of planetary motion, Earth moves faster when it is closer to the Sun and slower when it is farther away. At perihelion, Earth travels around 30.3 kilometers per second, while at aphelion, it slows to about 29.3 kilometers per second. Time itself, as measured in distance along the orbit, stretches and contracts subtly. Fact number 89. The orbital plane of Earth is called the ecliptic, and it serves as a reference for much of astronomy. The Sun, Moon, and planets all appear to move along this path from our perspective on Earth. This geometry shapes not only eclipses, but also how constellations and zodiac signs align with the sky through the year. Fact number 90. Earth's orbit also wobbles slightly due to gravitational pulls from other planets, particularly Jupiter and Saturn. These long-term variations, known as Milankovitch cycles, influence climate over tens of thousands of years. They are thought to play a role in the pacing of ice ages and warm periods throughout history. Fact number 91. The concept of the year so fundamental to culture, religion, and economy comes directly from this orbit. Agricultural calendars, financial systems, and global tourism seasons are all tied to the passage of Earth around the Sun. Geography experiences the result of astronomy's precise clockwork. Fact number 92. In many ancient cultures, Earth's orbit was imagined as a sacred path. Egyptians aligned temples with the rising sun on solstices, while Mayans built pyramids where shadows traced seasonal cycles. These monuments are echoes of humanity's awareness that Earth's motion through space shapes the world below. Fact number 93. The orbit is not fixed in space. Over time, the orientation of Earth's elliptical path shifts, a slow process called apsidal precession. Combined with axial precession, this gradual change alters how sunlight falls on Earth over thousands of years, further influencing climate patterns. Fact number 94. Even luxury industries and modern lifestyles depend on this orbit. From summer tourism in the Mediterranean to winter ski resorts in the Alps, Earth's path around the Sun dictates when and where humans seek leisure. Travel and economy orbit alongside the planet's celestial motion. Fact number 95. The length of Earth's year is also key to technology. Satellites, calendars, and global positioning systems must account for orbital mechanics. Without precision in tracking Earth's orbit, navigation and communication would falter, revealing how deeply space and geography remain entwined. Fact number 96. Our orbit is not unique, but it is unusually stable. Many exoplanets discovered around distant stars follow far more eccentric paths, swinging between extremes of heat and cold. Earth's gentle ellipse is part of what makes it habitable, balancing geography with cosmic harmony. Fact number 97. While Earth orbits the Sun, the entire solar system itself orbits the Milky Way galaxy. This greater journey takes about 225 million years to complete a single galactic year. It is a reminder that while we measure our time in months and years, we are part of far grander cycles. Fact number 98. The steady rhythm of Earth's orbit is also mirrored in culture. Festivals marking the harvest, religious holidays tied to solstices, and even modern celebrations like New Year's Eve all reflect humanity's effort to anchor itself within this cosmic cycle. Fact number 99. The future of Earth's orbit is secure for billions of years. Yet eventually, as the Sun ages and expands into a red giant, the delicate balance will shift. Our current year, with its familiar seasons, is just one chapter in the long story of astronomy and geography entwined. Fact number 100. To imagine Earth's orbit is to picture our planet as a traveler on an endless path, circling its star in perfect rhythm. Every sunrise, every season, every calendar page we turn is a reminder of this quiet, celestial journey. As this part closes, let yourself picture Earth's soft arc around the Sun, always moving, never stopping, shaping time itself. The orbit is invisible to our eyes, yet it governs our lives more than almost anything else. It is the bridge between space and Earth, between astronomy's vastness and geography's daily rhythm. As we float deeper into this story of Earth and space, it is time to turn toward our constant companion, the Moon. Though small compared to our planet, the Moon exerts a profound influence on Earth's culture and daily rhythms. It reminds us that our world is not isolated, but always part of a wider system where gravity and motion connect sky and land. Fact number 101. The Moon is about 1/4 the size of Earth, making it unusually large compared to the moons of other planets. This ratio has a powerful effect on Earth, stabilizing its tilt and giving us the predictable rhythm of seasons. Without the Moon, our axis might wobble wildly, leading to chaotic climate shifts. Fact number 102. The most visible impact of the Moon is on tides. Its gravitational pull draws Earth's oceans into bulges, creating high tides. As Earth rotates, coastlines pass through these bulges, giving us too high and too low tides most days. Geography determines how strong these tides appear: gentle along some beaches, dramatic in narrow bays. Fact number 103. The Sun also influences tides, though less strongly. When the Sun and Moon align during new and full moons, their combined pull creates spring tides with especially high and low waters. When they are at right angles, neap tides occur with more moderate shifts. Here, astronomy's geometry plays out on Earth's shores. Fact number 104. Some of the world's most dramatic tides occur in Canada's Bay of Fundy, where geography amplifies the effect. The difference between high and low tide can reach more than 16 meters. Local tourism thrives on this natural spectacle, as visitors witness boats lifted and lowered by the Moon's pull. Fact number 105. The Moon also influences Earth's rotation. Its gravitational pull creates friction within the oceans, gradually slowing Earth's spin. As a result, our days are slowly lengthening about 1.7 milliseconds per century. In distant geological time, days were shorter, with Earth spinning faster. Fact number 106. The Moon itself is slowly moving away from Earth at about 3.8 centimeters per year. Millions of years from now, total solar eclipses will no longer occur, as the Moon will appear too small to fully cover the Sun. What we see as a perfect celestial coincidence is only temporary. Fact number 107. Human culture has long been guided by lunar cycles. Many ancient calendars were based on the Moon, with months tied to its phases. Festivals, harvests, and religious observances often still follow lunar rhythms, from Ramadan to Lunar New Year. Astronomy here shapes human culture directly. Fact number 108. The Moon's phases have inspired poetry, art, and myth across civilizations. The waxing and waning arc was seen as a symbol of rebirth, change, and time's passage. Geography colors these interpretations, with some cultures seeing a rabbit in the Moon's surface patterns, while others see a face. Fact number 109. Beyond culture, the Moon has practical significance for navigation. Before advanced technology, sailors often used lunar observations to calculate longitude, aligning astronomy with geography to cross oceans safely. Fact number 110. Modern technology also relies on lunar understanding. Tidal energy projects, designed to capture the power of shifting waters, depend on accurate models of the Moon's gravitational pull. Here, nature and renewable energy connect space science to economic innovation. Fact number 111. Even ecosystems depend on lunar cycles. Sea turtles, for instance, often hatch at night, guided by the Moon's light to the ocean. Coral reefs time their spawning with full moons, synchronizing entire ecosystems with celestial patterns. Fact number 112. Tourism, too, finds luxury in lunar events. Travelers seek out places to view rare eclipses, supermoons, or the tranquil glow of a full moon rising over landmarks. From deserts to mountains, the Moon enhances landscapes, blending geography with the poetry of astronomy. Fact number 113. In mythology, the Moon was often paired with femininity, cycles, and fertility, while the Sun symbolized constancy and power across continents. This duality shaped rituals, beliefs, and even architecture. Fact number 114. Scientific exploration of the Moon has deepened our knowledge of Earth. The Apollo missions revealed that the Moon was once part of Earth, likely formed from a colossal impact billions of years ago. This shared origin means the Moon is, in a sense, a fragment of our own geography flung into the sky. Fact number 115. Looking to the future, the Moon may once again reshape human geography. Plans for lunar bases and resource extraction could transform not only space exploration, but also Earth's economy. The Moon, once a distant companion, may become a neighbor in trade and travel. As this section closes, imagine standing on a quiet shoreline at night, the Moon's light rippling across the water, its gravity tugging at the sea, its phases marking the passage of time. The Moon is more than a satellite, it is Earth's partner in an eternal dance, linking space and geography with grace and power. Let us now glide into a quieter but vital overlap of space and geography. Earth's magnetic field. Invisible, silent, and ever-present, it is our shield against cosmic forces. Without it, Earth's surface would be far less hospitable, exposed to streams of charged particles flowing endlessly from the sun. The magnetic field is born deep within Earth, yet it stretches far into space, shaping not only our environment, but also human history and navigation. Fact number 116. Earth's magnetic field is generated by movements of molten iron in its outer core. As this liquid metal swirls, it creates electric currents, which in turn generate the magnetic field. This natural dynamo links Earth's fiery geology to the protection of its atmosphere. Fact number 117. The magnetic field extends thousands of kilometers into space, forming what scientists call the magnetosphere. This region deflects much of the solar wind, a constant stream of charged particles from the sun. Without this shield, Earth's atmosphere could have been stripped away long ago, as happened to Mars. Fact number 118. The field is not perfectly stable. Its strength waxes and wanes, and the poles slowly drift. In fact, the North Magnetic Pole is currently moving across the Arctic at about 50 kilometers per year, requiring updates to global navigation systems. Fact number 119. Occasionally, over geological timescales, the field has flipped entirely north, becoming south, and south becoming north. These magnetic reversals, recorded in volcanic rocks, happen irregularly, roughly every few 100,000 years. They remind us that even Earth's deepest rhythms are dynamic. Fact number 120. The auroras, known as the northern and southern lights, are among the most beautiful expressions of Earth's magnetic field. When charged particles from the solar wind collide with gases in the upper atmosphere, they create glowing curtains of green, purple, and red light. Geography decides where they appear, near the poles where the field lines curve inward. Fact number 121. The auroras have become powerful attractions for global tourism. From luxury hotels in Lapland with glass-roofed igloos to cruises off the coast of Norway, travelers seek out these natural wonders, blending astronomy's forces with geography's landscapes. Fact number 122. Birds, sea turtles, and even some bacteria use Earth's magnetic field for navigation. This phenomenon, called magnetoreception, links cosmic energy directly to the daily survival of countless species. Migrations across oceans and continents may follow invisible magnetic maps written into biology. Fact number 123. Human navigation has also long relied on magnetism. The magnetic compass, invented in China over 1,000 years ago, revolutionized travel and trade, allowing sailors to cross oceans more confidently. It was one of the most powerful connections between space, physics, and global geography. Fact number 124. The magnetic field influences modern technology as well. Satellites, airlines, and even electrical grids can be disrupted by geomagnetic storm-sidden bursts of solar wind that disturb the magnetosphere. Protecting our infrastructure requires constant monitoring of space weather. Fact number 125. The South Atlantic anomaly, a weak spot in the magnetic field, is a reminder of its complexity. Over this region, satellites are more vulnerable to radiation, affecting technology and research. Here, geography on Earth intersects directly with conditions in space. Fact number 126. Archaeologists have used variations in magnetism to date artifacts. When pottery is fired, magnetic minerals inside align with Earth's field. By measuring this alignment, researchers can estimate the age of ancient objects, surprising overlap of geology, astronomy, and human history. Fact number 127. Though invisible, the field is a constant companion in daily life. Smartphones, airplanes, and ships still rely on magnetic sensing for orientation. In this way, a process that begins in Earth's molten heart reaches into modern technology, shaping travel, economy, and exploration. Fact number 128. Earth's magnetic field also has cultural echoes. The auroras were once seen as omens or spirits in the sky, guiding myths and beliefs. The compass changed empires, enabling exploration and global exchange. Magnetism's story is not just scientific, it is woven into human geography. Fact number 129. Without this shield, Earth would likely resemble Mars, stripped of its thick atmosphere and oceans. Life as we know it depends not only on sunlight and water, but also on this invisible guardian stretching silently across space. Fact number 130. To imagine the magnetic field is to picture unseen lines of force encircling our planet, bending solar winds, painting auroras, and guiding migrations. It is a perfect example of how astronomy and earth sciences meet in the most practical yet poetic ways. As this part concludes, think of Earth not just as a planet of land, water, and sky, but also as a magnetic traveler carrying its shield through space. It is a reminder that our safety, our journeys, and even our sense of direction are tied to forces far beyond our sight. Now, let us settle into one of the most graceful overlaps between Earth and space, the dance of the seasons. The tilt of Earth's axis, gentle and constant, creates rhythms that shape agriculture, culture, and even the flow of history. Each solstice and equinox is like a cosmic punctuation mark, dividing the year into chapters of light and shadow. Fact number 131. Earth is tilted at about 23.5 degrees on its axis. This tilt is the reason we have seasons. Without it, the sun's path would not vary much, and much of the planet would experience a single, monotonous climate. Fact number 132. During the June solstice, the northern hemisphere leans toward the sun, bringing longer days and shorter nights. In places like Scandinavia, the midnight sun becomes a magical reality, where daylight lingers even at midnight, creating both cultural celebrations and unique challenges for daily life. Fact number 133. At the same time, the southern hemisphere tilts away, welcoming winter. Argentina, South Africa, and Australia all mark this period with cultural and economic adaptations, ski tourism in the Andes, quiet winter festivals, and cozy traditions. Seasons are a mirror image across hemispheres, uniting the globe in contrast. Fact number 134. The equinoxes in March and September are the balance points of the year. Day and night become nearly equal across the entire planet, a rare moment of symmetry. For ancient cultures, these times often marked new beginnings, agricultural cycles, and religious rituals. Fact number 135. Stonehenge in England and the pyramids of Egypt are thought to align with solstices or equinoxes. These ancient monuments remind us how astronomy and geography guided architecture, ritual, and even political power. Fact number 136. Tourism follows the rhythms of the seasons. Ski resorts in the Alps thrive in winter, while Mediterranean beaches overflow in summer. The economy of travel, luxury, and leisure is synchronized with Earth's tilt, showing how space and geography influence modern lifestyle and global rankings in tourism. Fact number 137. The tropics are defined by the sun's path. The Tropic of Cancer and Tropic of Capricorn mark the northernmost and southernmost points where the sun can appear directly overhead. This astronomical boundary defines geographic regions, climate zones, and agricultural possibilities. Fact number 138. Monsoon patterns in Asia are directly tied to seasonal shifts. The heating of land and ocean at different rates drives winds that bring life-giving rains to millions of people. The economy, agriculture, and culture of entire civilizations depend on this cosmic geographic rhythm. Fact number 139. Festivals around the world celebrate the seasons. Midsummer in Sweden, Holi in India, Thanksgiving in the United States, and Lunar New Year in East Asia all reflect the cultural richness tied to Earth's celestial tilt. These traditions link astronomy to human joy. Fact number 140. Equinoxes and solstices also guide global calendars. While we often think of time as a digital constant, it is rooted in the changing position of the sun. Our months, years, and cultural rhythms are all chapters written by the tilt of the Earth. Fact number 141. In regions near the equator, seasonal changes are subtle. Instead of 4 distinct seasons, many equatorial places have wet and dry periods, still governed by Earth's tilt, but expressed differently in climate. This creates diverse ecosystems, like the Amazon rainforest, rich in life and critical to the global economy. Fact number 142. Seasonal cycles have also shaped history. Harvest failures caused by unexpected climate shifts influenced the collapse of civilizations, from the Mayans to medieval Europe. Understanding the overlap of Earth and space has always been essential for survival. Fact number 143. Technology today tracks seasonal changes with precision. Satellites measure vegetation, snow cover, and sea ice, allowing us to study climate change with accuracy. Here, astronomy's tools enhance geography's understanding, merging space technology with Earth's needs. Fact number 144. Luxury industries, such as fashion, are built around seasonal cycles. Collections shift with a calendar, tying cultural identity and global economics to the ancient tilt of our planet. Even what we wear is subtly influenced by astronomy. Fact number 145. The solstices and equinoxes remind us of balance, contrast, and rhythm. They show how Earth's path in space writes poetry into geography's sunlight and shadow. creating the beauty of seasons that shape not only landscapes, but also human imagination. As we close this part, think of how your own daily life, your meals, your holidays. Seasons are proof that space and earth are inseparable partners in the story of human existence. Now we step into one of the most dramatic overlaps of earth and space: eclipses. These fleeting events, when the sun, earth, and moon align in a perfect geometric dance, remind us of the interconnectedness of our world with the cosmos. Eclipses have fascinated humans for millennia, inspiring myths, guiding calendars, and today, drawing global tourism and scientific study. Fact number 146. A solar eclipse occurs when the moon passes between Earth and the sun, casting a shadow on Earth's surface. For those standing in the path of totality, daylight can vanish in mere moments, plunging the world into an eerie twilight. Fact number 147. A lunar eclipse happens when Earth moves between the sun and the moon, casting its own shadow across the moon's face. Unlike a solar eclipse, this is visible across entire hemispheres, making it more accessible to humanity at large. Fact number 148. Eclipses don't happen every month because the moon's orbit is tilted about 5 degrees compared to Earth's orbit around the sun. This small misalignment means that only occasionally do the sun, moon, and Earth line up precisely. Fact number 149. The longest total solar eclipse of the 21st century occurred on July 22, 2009, lasting 6 minutes and 39 seconds. Millions of people across Asia paused their lives to witness it, blending culture, science, and awe into a single experience. Fact number 150. Ancient cultures often viewed eclipses with fear or reverence. In China, eclipses were believed to signal a dragon devouring the sun. In Mesopotamia, they were thought to foretell the fate of kings. These myths highlight humanity's attempt to explain cosmic geography before science provided clarity. Fact number 151. Today, eclipses are a driver of global tourism. Travelers plan luxury trips to remote destinations, from deserts in Chile to islands in the Pacific, to stand within the narrow path of totality. This unique blend of astronomy and geography supports local economies and fuels cultural exchange. Fact number 152. The umbra, penumbra, and antumbra are the 3 parts of an eclipse's shadow. The umbra is the darkest part, where total eclipses occur. The penumbra creates partial eclipses, and the antumbra produces an annular eclipse, where a glowing ring of fire encircles the moon. Fact number 153. A total lunar eclipse often paints the moon in shades of copper and crimson. This blood moon effect comes from Earth's atmosphere bending and filtering sunlight, scattering blue light and letting red hues fall across the moon's surface. Fact number 154. The Saros cycle, lasting about 18 years. This cycle has been tracked since ancient Babylonian times. A fusion of astronomy and geography guiding calendars across civilizations. Fact number 155. Eclipses offer scientists rare opportunities. Observing the sun's corona during totality has led to breakthroughs in understanding solar winds, plasma physics, and even Einstein's theory of relativity during the 1919 eclipse. Here, space and Earth's vantage point unite in advancing education and technology. Fact number 156. Solar eclipses create dramatic changes on Earth's surface. Temperatures drop, animals behave as if night has arrived, and winds shift. These phenomena remind us how sensitive Earth's geography is to even temporary changes in solar light. Fact number 157. Not all eclipses are visible everywhere. Geography dictates who can see them. While a total solar eclipse may span a narrow strip of land, partial phases stretch across continents, connecting millions of people under the same celestial event. Fact number 158. Some of the most stunning eclipses are observed from unique geographic vantage points like mountain peaks, islands, or deserts. Tourism industries often combine these events with cultural festivals, offering travelers both luxury and knowledge in a single journey. Fact number 159. The next great eclipse, sometimes called the eclipse of the century, is anticipated in 2027, with totality lasting over 6 minutes and sweeping across North Africa and the Middle East. Nations are already preparing to welcome visitors, proving how space phenomena directly shape economies and travel. Fact number 160. Eclipses remind us of perspective. While they last only minutes or hours, they are windows into the deep connection between Earth's motion, the moon's orbit, and the sun's light. Shadows across our planet are written by celestial geometry, painting poetry in both science and geography. As we leave this chapter of shadows and alignments, we are reminded that every eclipse connects humanity villagers, travelers, scientists, and dreamers looking upward in wonder, grounded on Earth, yet connected to the cosmos. Now, let us travel to Earth's extremes, where geography and astronomy entwine most visibly. The polar regions. Here, the tilt of our planet and its steady orbit around the sun create phenomena that seem otherworldly: months of sunlight, months of darkness, and skies painted with auroras. Fact number 161. At the Arctic and Antarctic circles, located at about 66.5 degrees north and south, the sun can stay above or below the horizon for 24 hours at a time. This creates the midnight sun in summer and the polar night in winter. Fact number 162. During the midnight sun, places like Tromsø in Norway or Svalbard near the North Pole experience continuous daylight. For weeks, the sun lingers above the horizon, casting a surreal glow that blurs the line between day and night. Fact number 163. In contrast, the polar night leaves regions in darkness for months. Yet even then, the sky is not always empty. Moonlight, starlight, and the dancing auroras bring color to the long winter. Fact number 164. The midnight sun has inspired tourism industries in Arctic nations. Luxury cruises, midnight hikes, and photography tours attract visitors eager to witness this astronomic holographic wonder firsthand. Economies in places like Iceland and northern Finland thrive on this seasonal draw. Fact number 165. The polar night challenges daily life. Residents adapt with strong cultural traditions, community gatherings, and technology to manage limited daylight. Psychology and health studies explore how humans respond to these extreme rhythms of light and shadow. Fact number 166. Antarctica, Earth's southernmost continent, also experiences these polar extremes. But, unlike the North, it is largely uninhabited except for scientific stations. Researchers endure months of darkness, relying on astronomy-grade instruments to study both space and climate. Fact number 167. The aurora borealis in the north and aurora australis in the south are tied to space weather. Charged particles from the sun collide with Earth's atmosphere, creating curtains of green, red, and violet light. This is one of the most direct interactions between space and geography visible to the human eye. Fact number 168. Ancient cultures wove myths around the auroras. Norse legends saw them as reflections from the shields of warriors. In Finland, some believed the lights were caused by foxes brushing their tails against the snow, sending sparks into the sky. Fact number 169. Scientific study of auroras helps us understand space weather, which can impact technology on Earth. Solar storms that create brilliant lights can also disrupt satellites, communication systems, and even power grids, proving the practical importance of astronomy to daily life. Fact number 170. The polar regions also reveal Earth's role in regulating climate. Ice caps reflect sunlight back into space, helping stabilize temperatures across the planet. This interplay of light, geography, and space is crucial for understanding global warming. Fact number 171. Time zones are especially strange in polar regions. In Antarctica, multiple time zones converge, but research stations often use the time zone of the country operating them. In the Arctic, the international dateline bends dramatically to avoid splitting communities. Fact number 172. Indigenous cultures, such as the of northern Scandinavia, have long adapted to the polar light cycle. Their traditions, livelihoods, and cultural practices reflect a deep knowledge of geography tied to celestial rhythms. Fact number 173. The beauty of the midnight sun and auroras has inspired countless works of art, literature, and film. These natural spectacles connect science with creativity, showing how space phenomena enrich global culture and identity. Fact number 174. Polar research stations use the long months of darkness to simulate conditions for space exploration. Scientists living in isolation during polar winters contribute valuable insights for future missions to Mars. Here, Earth's geography becomes a stage for testing humanity's expansion into space. Fact number 175. The poles, with their extremes of light and dark, remind us that our planet is not uniform. Earth is a sphere tilted toward the stars, and its geometry with the sun writes experiences that vary dramatically depending on where we live. This is geography and astronomy intertwined in their purest form. As we leave the polar regions, carry with you the memory of endless daylight and endless night, two sides of a cosmic coin, both born from Earth's steady tilt and its journey through space. Now let us drift into another graceful overlap of Earth and space, the tides. This ceaseless rising and falling of the seas is a reminder that the moon, though distant, exerts a steady influence on our world. With its quiet pull, it shapes coastlines, guides marine life, and has even influenced human culture and economy for centuries. Fact number 176. Tides are caused primarily by the gravitational pull of the moon on Earth's oceans. Though the sun also plays a role, the moon's proximity makes it the dominant force in this daily rhythm of water. Fact number 177. Most coastal areas experience 2 high tides each day. This semidiurnal pattern occurs because, as Earth rotates, different parts of the planet pass through the bulges of water created by the moon's gravity. Fact number 178. Spring tides occur when the sun, Earth, and moon are aligned, during a full moon or new moon. These tides are especially strong, producing higher highs and lower lows. Neap tides, by contrast, happen when the sun and moon are at right angles, reducing tidal differences. Fact number 179. Some regions experience dramatic tidal ranges. The Bay of Fundy in Canada has the world's highest tides, with differences of up to 16 meters between high and low water. This geographic marvel is a direct expression of cosmic alignment. Fact number 180. Tides shape ecosystems. Coastal wetlands, estuaries, and tidal flats depend on the ebb and flow of water. Countless species of birds, fish, and shellfish rely on these environments, linking astronomy's gravitational pull to biodiversity and global food systems. Fact number 181. Human history has long been guided by tides. Ancient mariners studied tidal cycles to navigate harbors safely. Today, ports and shipping industries still rely on tidal charts, proving that global trade and economy are subtly governed by the moon. Fact number 182. Tides influence energy. Tidal power plants harness the predictable rise and fall of the seas, offering a renewable source of electricity. This blending of astronomy and technology shows how cosmic rhythms can fuel modern progress. Fact number 183. The moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. Over millions of years, this will lengthen Earth's day and weaken tidal effects, reminding us that even these timeless rhythms are part of a larger story of change. Fact number 184. Tidal forces don't just affect oceans. They also influence Earth's crust, causing slight flexing of land. In extreme cases, they can even affect volcanic and seismic activity, linking cosmic mechanics to geology. Fact number 185. Marine species have adapted to tidal cycles with astonishing precision. Crabs, mollusks, and fish time their movements, feeding and reproduction to the moon's gravitational rhythm. Life on Earth has ridden the moon's pull into its genetic code. Fact number 186. Some of the earliest attempts at predicting tides came from Islamic scholars in the medieval period and European astronomers during the Renaissance. Their efforts represent an early marriage of geography, astronomy, and mathematics. Fact number 187. The connection between tides and human imagination runs deep. Poets and writers have long used the imagery of the moon and tides as metaphors for longing, change, and time itself. Here, science and art flow together like waves on a shore. Fact number 188. Tourism often celebrates tidal extremes. Visitors to Mont Saint-Michel in France marvel at how the sea rises and falls dramatically around the abbey. Natural wonders like these bring together culture, history, and astronomy in ways that inspire global travelers. Fact number 189. Tides also reveal the power of perspective. What seems like a simple rhythm of water at the shore is actually a vast choreography involving Earth, Moon, and Sun. Every wave that touches a beach carries within it the pull of space. Fact number 190. Tides remind us that even our oceans are part of a celestial system. Geography is not separate from astronomy. Rather, the two are forever linked, shaping both our landscapes and our lives. As you picture the quiet sweep of water retreating and returning, imagine the unseen hand of the moon drawing the seas like a painter moving a brush across a canvas. This is the poetry of gravity written upon Earth by the cosmos. We now arrive at the final part of our journey, where we draw together the many threads of geography and astronomy into a single perspective: Earth's place within the wider cosmos. To understand the overlap of space and Earth is to see our planet as both unique and deeply connected to the universe that surrounds it. Fact number 191. Earth is the only known planet where liquid water flows abundantly on the surface. This simple fact defines geography, rivers, oceans, and climate sand. It is also what makes Earth distinct in the vastness of space. Fact number 192. Our atmosphere. A thin veil of gases creates weather, protects us from harmful solar radiation, and sustains life. From the auroras at the poles to the monsoons of Asia, this layer demonstrates how cosmic and terrestrial systems overlap seamlessly. Fact number 193. Earth orbits within the habitable zone of the Sun, a region sometimes called the Goldilocks zone, not too cold. Geography, as we know its mountains, valleys, rivers, exists only because our planet occupies this perfect distance. Fact number 194. Time itself, as humans experience it, is shaped by Earth's position in space. Days from its rotation, months from the moon's orbit, and years from its path around the sun all mark the rhythm of cultures, calendars, and economies. Fact number 195. Our planet's magnetic field is generated by molten iron moving deep within the core. This shield deflects solar winds, protecting the atmosphere and shaping the auroras. Without it, geography and life would be unrecognizable. Fact number 196. Earth's mountains, carved by tectonics, are also influenced by cosmic forces. The Himalayas, still rising, were born from Earth's restless plates. Yet their glaciers and weather are tied to seasonal rhythms created by our orbit and tilt. Fact number 197. The interplay between day and night, a result of Earth's rotation, shapes global economies. Tourism, agriculture, technology, and even luxury industries are synchronized with this cosmic geographic cycle. Fact number 198. The moon, our closest neighbor, not only shapes tides, but also stabilizes Earth's tilt. Without the moon's gravitational balance, our seasons could wobble unpredictably, making climate less stable and life more precarious. Fact number 199. Earth is part of the solar system, orbiting alongside planets like Mars, Venus, and Jupiter. Geography is not only about our own planet, but about understanding Earth's landscapes as one example within a much larger family of worlds. Fact number: looking further out, Earth belongs to the Milky Way galaxy. Our planet orbits a star that itself is one of billions, circling within a spiral arm of a galaxy that stretches more than 100,000 light-years. Geography, when viewed in this context, becomes a study of one island among countless cosmic seas. Fact number 201. Astronauts describe the overview effect, the profound realization of Earth's fragility when seen from space. From orbit, mountains, rivers, and borders vanish, replaced by the sight of one interconnected planet glowing against the blackness. Fact number 202. Earth's story is inseparable from space. Every sunrise, every tide, every season is written by a partnership between our planet and the wider universe. To study geography without astronomy would be to see only half the story. Fact number 203. Education and science now unite these fields, with schools teaching both earth sciences and space sciences side by side. From satellites mapping forests to telescopes watching galaxies, knowledge flows across both domains. Fact number 204. Technology makes this overlap practical. GPS, communication, satellites, weather prediction, and climate monitoring all rely on space-based tools to study and manage Earth's geography. This synergy of astronomy and geography powers modern civilization. Fact number 205. Luxury travel has begun to embrace the cosmic perspective. From northern lights, tours in Iceland, to upcoming commercial spaceflights, humanity is seeking experiences that connect Earth's landscapes with the vastness above. Fact number 206. Earth's economy, culture, and daily life are increasingly globalized, but at the deepest level, they are also cosmic. We are shaped not just by rivers and borders, but by orbits, eclipses, and stars. Fact number 207. Our planet, while unique, is part of a larger continuum. The search for exoplanets' worlds, orbiting other stars, extends the study of geography beyond Earth, showing us how landscapes, climates, and atmospheres may exist elsewhere. Fact number 208. The ultimate fact is this: geography and astronomy are not separate disciplines, but two perspectives on the same reality. One looks down, mapping rivers and mountains. The other looks up, charting stars and orbits. Together, they tell the story of where we are. And so, as our journey closes, let us pause and picture Earth, a blue and green sphere, bathed in sunlight, wrapped in clouds, spinning gently within a galaxy of stars. Every mountain, every ocean, every culture is part of a larger cosmic design. And every night sky we look upon is not just above us, but around us, enveloping our home in infinite wonder. This is the overlap of Earth and space, the poetry of geography, written in the language of astronomy.